Hi everyone. In this video, I'm going to explain all my answers from the addressing modes quiz. I'll walk you through each exercise, explain how I got the answers, and break everything down so it's super easy to understand. Now let's dive in. I'm Schneider's S. Villanueva. For exercise 1, identifying addressing mode. All right, exercise 1 is all about identification. The big question here is, how does the CPU know where to get the data? So here's the quick trick for this one. So if you see the brackets, the brackets, that means memory. No brackets, that's a register or immediate value. So let me show you what I mean. So for number 1, uh, mov AX, comma BX. So both operands are registers, no memory info. So the answer is register addressing. Number 2, mov AX, comma bracket 1, 2, 3, 4, H. So here we have brackets with direct memory address inside. The CPU goes straight to that address and that will fall to direct addressing. Number 3, mov AL, comma bracket SI. So SI is a register, but it is inside brackets. That means SI is acting as pointer to memory. So the answer for that, therefore, is register indirect addressing. Number 4. Mov bracket BP plus DI, comma AX. So two registers combined inside brackets. BP is the base, DI is the index. Therefore, the answer is based indexed addressing. Number 5, mov CX, comma bracket BX plus SI plus 08H. Same as before, but now we're adding displacement. So this falls under base indexed with displacement. That's simple. Number 6, mov bracket DI AX, single register inside brackets. It's pointing to memory. Therefore, the answer for that is register addressing. Number 7, mov AX, comma bracket BP minus 10H. Base register BP with a displacement. Therefore, the answer is base with displacement. For number 8, mov AX, comma 578 H 578H. So the value is right there in the instruction, so no memory lookup needed. So the answer for that is immediate addressing. And last for number 9, mov AX, comma bracket BX. So BX is inside bracket, so it's pointing to memory. Therefore, the answer for this one is register indirect addressing. That's all. That's it for exercise 1. So remember, brackets means memory. No bracket means register or immediate values. That's the key to identifying addressing modes. Next on exercise 2, writing code example. Now for exercise 2, I had to write a code that demonstrate addressing. So let me show you. Number 1, immediate addressing. Mov AX, comma 5 AAH. So the data is directly in the instruction. That's immediately addressing. Number 2, register addressing. Mov AX, comma PX. We're moving data between two registers. Simple as that. Number 3, direct addressing. Mov AX, comma bracket 1234H. So go to memory address 1234H and grab what's there. Number 4, here. Register indirect addressing. Mov AX comma bracket SI. SI holds the address. We follow the pointer. And that's it. Move AX SI. Number 5, index addressing. Move A L comma bracket DI plus 10H. So start at DI and at 10H. That's your final address. Number 6, based index addressing. Move AX comma bracket BX plus SI. So combine two registers to calculate the address. Pretty straightforward, yes. So each addressing mode has its own purpose and how to write code for each one. So going to exercise 3, address calculation or the physical address calculation. All right, this is where it gets a little mathematical. We need to calculate the actual physical address in memory. So the formula for 8086 is physical address equals segment times 10H plus offset. So let me show you examples. So problem 1, mov AX comma bracket 1000H. We're given with segment equals 2000H, offset equals 1000H. So step 1 is to multiply segment by 10,000 by 10H. 2000H times 10H is equal to 2000H. Step 2, add the offset. So 2000H plus 1000H equals 2021. Oh, I'm so sorry. It's not 2000, it's 20,000. So going back, saan tayo? So here we multiply 20,000H times 10,000H, which is equals to 20,000H. And 20,000H plus 1,000H is equal to 21,000H. I'm so sorry for that. And that's your physical address. Problem 2, compute the physical address, move AX, BX plus SI plus 10H with BX 1234H and SI 4321H. So the problem number 2, move AX comma bracket BX plus SI 10H. So we are given BX equals 123H, SI equals 121H, and displacement equals 10H. So first, calculate the offset. 1234H plus 4321H equals 555H. And 555H plus 10H equals 5565H. So now calculate the physical address. Segment times 10,000. 2000H times 10,000 equals 20,000, right? So 20,000 plus 5565H equals 25565H. So the final answer for this is 25565H. And that's it for the exercise 3. So remember the formula, segment times 10H plus offset. That's how you calculate physical address in 8086. So let's get straight to exercise 4, debug and analyze. So now for exercise 4, we're going to do some debugging. Part 1, ask us to identify addressing modes. So let me go through each instruction. Mov AX comma bracket SI is address register indirect. Mov SI comma 2000H immediate addressing. Add AX comma bracket SI plus 10H register with displacement or indexed addressing, and mov bracket DI comma AX. Excuse me. Register addressing. So for part 2, if the value add memory location 2000 H is 1, 2, 3, 4H, and at 2000H plus 10 is 567. What will be the final value of AX? So for part 2, it asks, what's the final value of AX? We are given at memory location 2000. The value is 1, 2, 3, 4H. At location 2010H, the value is 5678H. So let's trace through the code. Line 1, mov AX, comma, bracket SI points to 2000H. So AX gets the value at 2000, which is 1234H. AX equals 1234H. For line 2, mov SI, comma, 200H. SI is set to 2000H. For line 3, add AX, comma, bracket SI plus 10H. SI plus 10H equals 2010H or 2010H. The value at 2010H is 5678H. So we add 5678H to AX. And 1234H plus 5678H equals 68ACH. So moving to line 4, mov bracket DI, comma, AX. This just stores AX to memory, doesn't change AX. So final answer therefore is AX equals 68ACH. So for the last exercise, exercise 5, practical problem. So we need to write a complete program that stores a value at memory location, 3000H, retrieves it using their addressing, copies it to BX using register addressing, and stores it at location 4000 using register indirect addressing. So here is my code. Step 1, store ABCDH at 3000, mov AX, comma, BH ABCDH, and mov bracket, comma, AX. We load the immediate value into AX, then store it using the direct addressing. Step 2, retrieve it back into AX. So mov AX, comma, bracket 3000H, direct addressing to read from memory. Step 3, copy AX to BX. Mov BX, comma, AX. So simple register to register transfer siya. The number 3. I see step 3. Step 4, store BX location pointed by DI. So first, set DI to 4000H. Mov DI-H, then store BX at location. Mov bracket DI, comma, BX. Let's register indirect addressing. And that's the complete program. It demonstrates 4 different addressing modes working together. So that's my complete explanation for all the exercises. We covered how to identify addressing modes, how to write assembly code for each mode, how to calculate physical address, and how to debug and trace code execution. And thanks for watching, and I'll see you in next video maybe. Yeah, bye.